This is chapter 5.5, factoring using special patterns or factoring using special product patterns. Your assignment will be page 252, 20 through 36 even, and 38 through 44 even. They are separated because the directions for 38 through 44 even will be to factor out a greatest common factor. There are two types of special patterns or special product patterns. There's the difference of two squares, and there are perfect square trinomial patterns. What you learn in chapter 5.5 will be instrumental in helping you in chapter 6.5, where you are factoring with larger exponents or polynomials of a greater degree. For the difference of two squares, the first and last terms are perfect squares. They will be quadratic binomials, and the terms will be separated by subtraction. Hence the name difference relates to subtraction. Binomial means two terms. Okay, on page 249, the checkpoint exercises, number 1 is x squared minus 36. It meets the difference of two squares criteria in that the first term x squared and the last term 36 are perfect squares, that it is a quadratic second power binomial, two terms, and that the terms are separated by subtraction. So we know that the square root of x squared is x, so for both of your factors would be x, and then we know that the square root of 36 is 6, so we know that the other factor inside each of the binomials would be 6. Because you need a middle term to go away, you could use either FOIL or the table method to check this. It would have to be plus and minus, or addition and subtraction. So your factored amount for x squared minus 36 is x plus 6 times x minus 6. This is called a sum and difference pattern. I'd like you to try number 2, r squared minus 100, which is again the difference of two squares. It meets all the criteria, and that will give you a sum and difference pattern. When you are finished doing that, turn your recording back on to check your answer. For number 2, r squared minus 100, the difference of two squares, the square root of r squared is r, so that's your first term in the binomial. Square root of 100 is 10, so that's your second term in each of the binomials. In order for the middle term to go away, it has to be plus minus, so it's going to be r plus 10 times r minus 10. The difference of two squares factors to a sum and difference pattern. Okay, we're going to move on to some that are a little bit more involved. Okay, number 3 is 9m squared minus 64. Again, it's a difference of two squares, two terms, a quadratic binomial. It's to degree of 2. And separated by subtraction, and 9m squared and 64 are all perfect squares. Square root of 9 is 3. Square root of m squared is m, so it's 3m for your first term in the binomial. Square root of 64 is 8, so your second term in the binomials are 8. Because the middle term goes away, it has to be a plus minus or a sum and difference pattern. So 3 plus 8 times 3m plus 8 times 3m minus 8 is the factoring for 9m squared minus 64. Go ahead and try number 4. The only difficulty with number 4 will be what is the square root of 1/4? See if you can figure that out. What times what equals 1/4? Okay, number 4 is 1/4 p squared minus 81. Square root of 81 is 9. Square root of p squared is p. And if you think of 1/4 as the square root of 1 over the square root of 4, you'll get 1/2. Or think 1/2 times 1/2 equals 1/4. So it's 1/2 p plus 9 times 1/2 p minus 9. That is a sum and difference pattern. That is the factored amount of this difference of squares problem. All right. Okay, another type of special product patterns are the perfect square trinomials. And in a perfect square trinomial, like the difference of squares, the first and the last terms will be perfect squares. So those are their two similar parts. The next attributes differ. Instead of being a quadratic binomial, it is a quadratic trinomial. It also differs in that the middle term will be the product of the two terms doubled. We don't look at subtraction or addition in here. We make judgments as we do the problems. In x squared plus 10x plus 25, x squared is a perfect squared and 25 is a perfect squared. The square root of x squared is x, and the square root of 25 is 5. Since it is plus plus in the trinomial, it has to be plus plus for the binomials when you're factoring. And you are going to end up with x plus 5 times x plus 5. Those binomials are identical, so you would say the answer is x plus 5 squared. Now the name is important because it tells you exactly what you're getting. You have the binomial x plus 5 and you're squaring it. So the name of this is the square of a binomial. In order to determine if your middle term is in fact 10x, take the x here and the 5 here and multiply them 5 times x and then double that. So the middle term will be the product of the two terms, x and 5 doubled. So 5 times x, double it, it's 10x. Please try number 6. 4x squared plus 12x plus 9. Okay, so if you look at number 7, it's a perfect square trinomial because 9 is a perfect square, first term, p squared is a perfect square as well. 16, the last term, is also a perfect square. When it's a perfect square trinomial, you know that it'll factor such as this, and then these two will be exactly the same, those two factors, and then you're going to have a binomial in here squared. If it is a subtraction here, this becomes a little bit more challenging. You just have to pay attention to that. And what we're going to be deciding is what these operations are going to be. Let's start with the simple. Square root of 9 is 3. Square root of p squared is p. Coming over to 16, square root of 16 is 4. Square root of 16 is 4. And so the last thing you have to determine is, will it be plus plus or minus minus? And one of the ways to help yourself with that is just to assume that since when it's plus plus, it's going to be probably end up being minus minus. So let's just check that and make sure we're right. So we'll do a quick table method. You could also use FOIL. So we have 3p negative 4, 3p negative 4. 3p times 3p is 3p squared. That checks out. Or 9p squared, excuse me. 3 times 3 is 9. 9p squared, that checks out. 3p and negative 4 is negative 12p. Negative 4 and 3p is negative 12p. Well, negative 12p and negative 12p is negative 24p, so that checks out. And then the last one is negative 4 times negative 4, which is 16, and that does check out. So we know now that we were correct in putting 3p minus 4 times 3p minus 4. So the final answer is 3p minus 4 squared. So when you factor a perfect square trinomial, you in fact get the square of a binomial. Now, 8, 9, and 10 will involve either a perfect square trinomial, or it will involve a difference of two squares. The difference will be that you will first have to factor a number out, and I'll call that the GCF, the greatest common factor. So if we look at number 8, go ahead and write that down. 8, 5x squared plus 10x plus 5. You can always pause the video to write this stuff down. You will see that 5, 10, and 5 have a common factor of 5. So you are going to factor out the 5. And you are going to have 5 times what? Let's put factor out of 5. 5 times what is 5x squared? Well, that's x squared. 5 times what is 10x? Well, that's 2x. 5 times what is 5? Well, that's 1. Now, if you pay attention, you will see that you have perfect square there, perfect square here. And so you know that it is a trinomial, perfect square in the first and last terms, so you then know that it is a perfect square trinomial. And if it is a perfect square trinomial, first term and last term again are perfect squares, then it's going to be, and because this is plus plus, it's going to be this plus this. These will be identical binomials. Don't forget to bring that 5 down. That's kind of a common error, is to forget to bring that along. So make sure you bring that 5 along. And when we're finished, we're going to end up with 5 times something plus something squared. That will be our final answer. It'll be the square of a binomial. So this will be a binomial, it'll be squared. So the square root of x squared is x. The square root of 1 is 1. 1 times 1 is 1. So it's 5 times x plus 1 times x plus 1. These are identical, so we square them. X plus 1 squared. All right, let's go to this next one. This next one is a binomial. So immediately, if you're thinking of anything, it would be a difference of two squares. But 8 is not a perfect square, nor is 18. But before we say, oh, it's not a difference of two squares, we want to see if we can factor something out. So 8 and 18 have 2 in common. So we are going to factor out a 2. And it's going to be 2 times what is 8y squared? Well, that's 4y squared. 2 times what is 18? Well, that's 9, so minus 9. And now you can see that you, in fact, do have a perfect square here, 4y squared, and a perfect square here, 9. So it is now the difference of 2 squares. Don't forget to bring down your 2. And square root of 4 is 2. Square root of y squared is y. And square root of 9 is 3. Now this is a difference of 2 squares, which will come out to be a sum and difference pattern. So we are going to have the exact same thing with one with a plus, one with a minus. So 2y plus 3 and 2y minus 3. That's going to be your final answer right there. Okay, we're going to go on to 10. So that one is slightly more difficult, not much more. Okay, so we have 10 is 12u squared minus 36u plus 27. At this moment, it's not a perfect square. 12, the first term, and 27, the last term, are not perfect squares. However, if we factor out the greatest common factor, and if we look at this, 12, 36, negative 36, and 27 all share a 3. So 3 times what gives you 12u squared? That would be 4u squared. 3 times what gives you negative 36u? That would be minus 12u. 3 times what gives you 27? That would be plus 9. Now you can see that you in fact have a first term, 4u squared, that's a perfect square, and the last term, 9, that's a perfect square. Okay, so now when it's a perfect square trinomial, we're going to end up with this 3 times. And you're going to have 2 binomials, and you're going to know that they're going to be identical. It's not going to be plus plus because you've got this subtraction here. So it's going to be minus minus, and then it's going to be 3 times some binomial squared because it's the square of a binomial. So we're going to circle that. So if we take the square root of 4, it's 2. The square root of u squared is u, so 2u. If we take the square root of 9, it's 3. And so we have 2u minus 3 times 2u minus 3. And that is the identical binomial, so we write it as 3 times 2u minus 3 squared. Now let's talk about that middle term just a little bit more, because it's not critical for this, but it's nice to know. If you were to take the 2 factors right here, the 2u, and multiply it by this factor of 3, negative 3, you would get 2u times negative 3 is negative 6u. You would double it, it's negative 12u. There it is right there. Let me go up a page and talk about another perfect square trinomial. So here we have, let's do this one, number 7. So we have 3p and negative 4. We're going to multiply those 2 factors together. So 3p times negative 4 is negative 12p. You double it, it's negative 24p. By knowing these patterns, you're able to go back and forth between factoring, which is like division, or if necessary, if you're given the product of 2 binomials, then you can multiply them and come up with the product, which is then going to be your perfect square trinomial or your difference of 2 squares. So by knowing these patterns, you're able to go back and forth. Whether you're multiplying or factoring, you're able to go back and forth very easily. This concludes Chapter 5.5, Factoring Special Patterns. Your assignment is page 252, 20 through 36 even, and that make sure you write down the even part. That's one type of thing they want. And then on 38 through 44 even though there's no breaks, I put it separate because you are going to need on those, all of those, to factor out a common factor.